Well, hello there. I just wanted to make a quick little video to talk about the new LED boards that we've had manufactured. The LEDs came in the other day, and I spent a few hours reflowing them onto the boards, and I'll show them to you in just a second. I want to let you know that that reflow process worked perfectly. I didn't have any issues at all. I didn't film any of it, so unfortunately I can't show how I did that, but I think in one of the previous videos I pointed to a link of somebody doing it, so maybe I'll add that down in the description below again, just so you can see the process of reflowing a double-sided board. However, when I went to test these boards, I discovered that I had made a pretty bad mistake. Now, these boards with the large board size, the manufacturing, having a stencil made, and the shipping of all that cost over $50. And as they came out of the box, almost none of them are any good. Now, good news, they're fixable. Uh, but the problem I had, and if you can see on the screen behind me, you can see the KiCad 3D image display there. The problem is, I won't call it an issue. The way KiCad works is a little different from what I was used to working, and something that I didn't work. So I'm going to take you over to that and show you that. Okay, so what you're looking at here is the 3D model of one of the 5 LED boards. And on the side, this is the side that would be facing the board, the LEDs shining through the holes. And on the other side, now I don't have the 3D components on here, but on the other side of that are 4 pads for the 5-volt input, the ground, the input signal, and the output signal. And if I zoom in on this, you can see that the 5-volt and the ground are connected together. And you know what? That doesn't work. It just doesn't work. Now, if you look in here, you can just vaguely see that there's something going on that looks like it shouldn't be like this. It's like something got covered up. Well, what happened is I created a fill area around the 5-volt pad, and I connected the 5 volts to it. And then, now on the other side of this board, let me swing back to the other side. This is all 5 volts. Then that's nice and clean. So the 5 volts gets connected to where it needs to get connected to. This pad is ground, so it gets connected over here, and all of that is good and hunky-dory. However, on this side, it got merged together, and the reason for that is that I created this 5-volt pad first, and then I created a fill area for the whole board for the ground plane. Now, in all of the other CAD programs that I've used, when you had 2 different pore areas, one on top of the other, it would isolate those pores and keep them separate. Well, apparently KiCad doesn't do that. And another unfortunate thing, and I won't be able to show you on here, but I'll take you to the schematic, is if you look over here, you can see that I have these little cut pads for if, or little shorting pads actually. So if I don't use an LED, I just short this out and it shorts the input to the output. Well, this shorting pad is for this LED right here. The 3 LED, and that shorting pad is for the LED on the far end. These other 3 pads have their shorting pads underneath them. Well, that means that the footprint for the LED and the shorting pad are overlapping. So when I ran the test thing, I got errors saying that footprints were overlapping. I didn't look close enough and notice that it was saying that the 5-volt and ground was overlapping, because I knew I was going to get pads overlapping. So I thought that was an expected error, and it wasn't. So anyway, now I'm going to take you to a scene with the camera pointing at my desk here in a second and show you how this is fixable, what the boards actually look like. So let me take you to another board to show you how this ought to be laid out. Okay, I've got another board up here that I've already modified, and I'm going to have to do this to all of them for our next order. But what I've done is I've manually isolated the 5-volt pad from the ground pad so that they aren't connected. And on the other side of the board, you can see that this is the ground pad, and it's all nice and clean. And you got your 5 volts connected there. You got your ground on the other side connected over there. Life is good. This one will work. And when I run my error check, I only get the errors that I am supposed to get. So let me take you to a camera facing down at my desk, and I'll show you what the board looks like today, and what I have to do to fix it. Now, I only have one camera hooked up on here right now, so you won't see my lovely face while I'm showing you this, but such is life. No problem with my webcam getting it to focus correctly on this board. So I've reverted to a handheld phone to do this recording, and I'm sorry about that. But so this is what the board looks like after the LEDs and capacitors for those LEDs have been soldered on. And as you can see, they look really good. No problem at all. And the back side of the board, which is covered with the connectors, also look perfectly fine. They didn't fall off or shift or anything. Now, when you look at these connectors, like right there, you can see that I have the power and the ground shorted together, and of course that's not going to work. So the way I can fix this manually is by taking a Dremel tool and cutting a island out around that 5 volts to make it work. And I've done that one time right here. Now, I do not have a fine bit tool. I have one on order. It'll be here tomorrow, and I'll be able to do this with a little more delicacy. I tried to use a cutting wheel on the next one, and as you can see, I went and cut right through one of my traces. That's fixable, but I gave up on that immediately. So I'm waiting for a small Dremel tool to come in so I can go and whack around each of these 5-volt 5-volt pins to isolate them from the ground so that they'll work. It was a stupid mistake, and it's going to add a little more work to the process, but that's the whole job of proto boards, is to test out your prototype and see if you've made some stupid mistakes, and be proud of your mistakes. If you don't make mistakes, you're not learning. So that's it. I will maybe catch a little quick video after I get these modified to show you what the modified ones look like in earnest, and then we'll be installing them in the pinball machine. Okay, I said that I would show you a schematic of what exactly I did and what the problem was with the overlaps. And if you look right here, you can see the LED pads. These are the 4 big pads kind of on the outside, And if you look on the inside, there's two other smaller pads, and these are the shorting blocks. So the input signal comes in here and would normally go to the LED, which would then regenerate an output and send it on to the next LED down the string. But if you don't want to put this LED on because a particular place where you're using this card doesn't have a hole here for an LED, you can leave the LED off and just short this connector out, and that'll send the input or the output from the previous LED on to the input on the next LED, skipping over this one. Well, that architecture or that design causes you to have two footprints that are overlapping, and that will cause errors when you run your error check. So if I click up here on the little bug to perform the rule checking and tell it to run the DRC, you can see that I get a bunch of errors. Now, I just assumed, and you should never assume when you're checking errors, but I assumed that all of these copper area, inside copper area errors were caused by the fact that I had these overlapping footprints. But it's not. This is talking about the 5-volt and ground planes overlapping on that fill area that I needed to fix. So if I go farther on down here, you'll see that I have errors saying my courtyards are overlapping. And the courtyard is the little lined area that's drawn around a part that says don't put any parts inside this part because this is taken up by the part already. So I got two courtyards overlapping, and I get this area that says that a jumper is overlapping a diode. Well, that's the error I should have been expecting. I'm a bit of a novice at KiCad, so this is a learning experience for me. So anyway, I fixed that. By the way, nice big arrow here for that. Somewhere, if I go down here and look at, there's more arrows, but right here is the 5-volt pad behind here. And this is where I'm getting those 5-volt overlappy errors. I think if I turn off the front copper, yeah, you can see that there's my 5-volt pad, and I have the errors on this overlapping. So had I done just a little bit more research, I would have found this. And unfortunately, I have like 5 or 6 different types of boards, and every one of them has this error because I just took one board and I modified it, shrunk it up, moved components around to make it another board, but I had only done this power thing one time and I used it for all of them, so it was screwed up on all of them. Except I do have a few, just to fill in the space on the board, I had a few single circuit boards, and those are just fine. So not 100% of the parts are bad, but 95% of them are bad. So anyway, that's it. I really appreciate you guys watching, and hopefully we will still be able to get together on Monday and film something, so I'll see you in a couple of days.